Hey guys, go ahead and get out your note sheet for our 4-2 writing equations from patterns. So this isn't in your notes, but we're going to just take a quick look at an intro of how you can write equations from patterns, and this is a picture pattern instead of a number pattern. But what we can do is we can total up the number of these rectangles in each of the figures. So figure 1 had 4, figure 2 had 7, and figure 3 had 10. So it might be obvious that each time you're adding a row of 3. And what that would really mean, as we relate it back to what we've been talking about, is that the rate of change, which is changing each time, is that you're adding 3 blocks. So that actually becomes your slope. So that's y equals 3x. And then your y-intercept would be that extra amount besides multiplying the figure by 3. What was that extra amount that you had each time? And if you look across this top row, there was that one extra block that each of these had. So besides adding groups of 3, we have that one extra. So y equals 3x plus 1 is the actual equation for this pattern. And not all of them are that obvious. This was just kind of a nice one to see because it's obvious since you have that single one there. But that's really what you're doing. The amount you're adding each time's your slope. The additional amount would be your y-intercept. All right, so this was actually meant to be taught before you learned slope-intercept form, so I decided this year that was silly, so I changed it and we're doing it now, which should be pretty easy considering what we've just talked about with slope-intercept form. So equations must be written in y equals mx plus b format. M is the change of y divided by the change of x, and that's actually the slope because we did learn that. And then b is the y-intercept, and that really represents where that pattern begins, like on that first visual I just showed you guys. So your steps for doing this, steps 1 and 2 are finding the change in range and then finding the change in the domain, and ultimately that's finding the slope now that we know what slope is. Again, keep in mind this was supposed to be taught before slope-intercept, which in my opinion is silly, so we changed it. And then step 3 says to substitute your slope m into the variable m in your equation. And then you would have to solve for your y-intercept, which is b. And the way we would do that is either pick a set of ordered pairs, plug them in, and then figure out what b is. Or in some patterns, what you can do is you can work backwards. Since you know a y-intercept is when x is 0, depending on what kind of pattern you have. You can figure out in the table when x would be 0, and then that y value would automatically be your y-intercept. So once again, we kind of already looked at this, so this is kind of just review, but find slope, figure out what the y-intercept would be, and write your equation, and you're done. Okay, so what we're going to do here is first find the slope, and again, what we've been talking about is slope is the change of y over the change of x. So we don't have to use the actual slope formula because when you have a table like this, if you want the change in y, just look at your y's and say, well, what am I doing to go from 1 to 2 and 2 to 3? I'm adding 1, so that's going to be a 1. And then look at your x values, and the change of x each time is from -4 to -8 to -12. You're getting smaller by 4, so your slope is just -1/4. So again, we would take that and we would substitute that in for m, and then we would have to figure out, well, is there anything else you're doing besides multiplying the input x by -1/4 to get your output y. So you can pick a pair from here. I'll just pick that first one, and y was 1 when x was -4, and I'm going to see if this works. So is -1/4 times -4 going to give me 1, or is there something else that b would have to be in order for this to be true? And if I evaluate, that does give me 1, and that basically tells me that I'm not doing anything else. So b would actually be 0 in this case. So your final thing is to just understand that the equation then would be y equals -1/4 x. B would be 0, so you can write it as plus 0, or you can just put -1/4 x. Okay, so your second one, again, we're going to start with finding your slope, and your slope is your change of y. So if you look at your y values, 4 to 7 to 10 to 13 to 16, we're increasing by adding 3 each time, so that's your numerator. Your change of x is how your x's are changing, and that's adding 1. So we've got a slope of 3. We're going to go ahead and substitute that in for m. And then we're going to have to figure out, is there anything else besides multiplying the inputs by 3 that I need to do in order to make this fit this table. So if you pick an ordered pair group, and again, I usually pick the one that looks the easiest, so I'm going to use 1 and 4. So they're saying when your input was 1 for x, and that's going to get multiplied by your slope, which was 3, that our output needs to be, according to this table, a 4. So if I do this math, 3 times 1 is 3, so I clearly see that that's not 4. So if I solve for b, I can subtract 3, or you should be able to look at that and say, well, b is going to have to be 1. Which means your y-intercept here is 1. Now, the other way you could have done that, like I said, this pattern was nice because it's 1, 2, 3, 4, 5 for x's. So technically, your y-intercept is if x was 0. So if you took this pattern backwards 1 to where x was 0, and you work backwards once on your y values, you would subtract 3, and that y value right there would be 1. And that tells you right then and there, if x is 0, then your y-intercept is actually 1. So our final step to write your equation, and then you're done. Okay, example 3, so change of y is adding 1 each time, change of x getting smaller by subtracting 2. So it looks like we have a slope of negative 1/2. So I'm going to go ahead and plug that in for m. And then I'm going to figure out, is there anything else we need to do? So we're going to go ahead and pick one of these ordered pairs. I'll pick the last one this time, so I'll use negative 10, 7. So that says when the input is negative 10 for x, that my output is supposed to be 7. So I'm going to figure out if I need to do anything else. So negative 1/2 times negative 10 is 5. 5 plus b needs to be 7. And if I continue to solve for b, I'm going to subtract 5, and then b would be 2. So your starting point of this pattern is 2, and then every time it's decreasing by negative 1/2. So your final answer, y equals negative 1/2 x plus 2. And technically, again, with this one, you could have taken this pattern backwards one because the numerator's x's are going by negative 2's. If you went backwards, you would add 2, and that's going to be when x is 0. And if you go backwards once on the bottom, that would be 2, according to the pattern for y's and x's. And then again, right there, you see that y-intercept is 2. Okay, so then example 4, if we take a look at our slope, change of y, 8 to 6, 6 to 2, 2 to 0, 0 to negative 8, I'm realizing is not consistent. So that's okay. That just means that this table, they didn't list the ordered pairs in a nice order for you. It doesn't mean this is wrong. And watch and see what will happen. So from 8 to 6 is minus 2, 6 to 2 is minus 4. Then we go back to a minus 2, and then we go to a minus 8. Now, if we check out the x, this should not be consistent either if the y is not. So from 1 to 2 is plus 1. From 2 to 4 is now plus 2. 4 to 5 is plus 1. 5 to 9 is plus 4. So I know it's different, but if you actually represent your slope, just pick one of these and do the change of y and the change of x that it matches up with. And that one was negative 2 over 1. If I look at the next one, that's going to be negative 4 over 2. And if you think about it, that's exactly the same thing as negative 2 over 1. And then our other one over here, negative 8 over 4, again, it's the same thing as the other two slopes. It's just they're not reduced. So it's okay. That still means your slope is simply negative 2 over 1 or negative 2. So I'm going to go ahead and plug that in. And then we're going to pick a point, any of these, and I'm actually going to use this 5, 0, and check in. And I'll see if b has a value to it in order to make this true. So plug in 0 and 5, and negative 2 times 5 is negative 10, plus b needs to be 0. And I'm going to go ahead and add over 10. And that means that my pattern's not just multiplied by negative 2, but then it's also added with 10. So my final equation here should be negative 2x plus 10. And if you ever want to check these, I kind of forgot to mention this, just pick another ordered pair from your table and plug it in for x and y and make sure it works. So if I wanted to try that with the 1 and 8, and I plug a 1 in here, then I should get my output to be 8. So -2 times 1 is -2, and then plus 10 would give you that 8. And it should work for all ordered pairs in this table, since that is the equation for every point that would be on this line. So these aren't on your notes, but if you wanted to practice any of these and see if you can maybe figure out 1 or 2 of them just to see that you've got this concept figured out before class, go ahead and pause it. You can try some and then press play if you want to check and see how you did. So number 1 should have just been y equals 12x, and you can have plus 0 if you want, but it's just multiplying every x by 12. Graph 2, or example 2, should be y equals 1/2 x plus 1, so you're cutting the x in half and then adding 1. Number 3 was 3x minus 2, or triple the x value, but then subtract 2 to get those y's. And then number 4 was 4x plus 5, so multiply by 4 and then add 5 to each of those. So hopefully you did pretty good with that. Next on your notes, I do have some calculator steps. We will talk about that in class next time, so I could show you how those work. But yes, there is a way to do these on the calculator. They're not that hard to do by hand, though, so you will get in the habit of doing this by hand as we do more. And then the back of your note sheet, don't worry about doing that. We're going to do that in class as well to practice with your calculators. So I will see you guys soon.